people want to lose fat. Many people are athletes who need to lose fat. Now, this is a huge topic on the internet. There's a lot of controversy. Today, we're going to talk about some things related to fat loss and that are powerful for fat loss that I'm guessing most of you have never heard about before. You may have heard about a few of them, but I'm guessing you haven't heard about all of them. However, I would also be remiss if I didn't mention an incredible study that was done by my colleague, Aaliyah Crum at Stanford. She's a faculty member, a professor in the psychology department, looking at how belief effects, just thinking, can impact the effects of things like exercise on weight loss. These are just incredible results. What they did was they took subjects who were hotel service people that would clean the hotels and come in and change the linens and so forth, divide them into two groups. One group, they were told, moving around and doing your duties for your job, meet the standards for U.S. guidelines for activity and movement, etc., and a basic lecture about how movement is good for you, etc., but mostly just that their daily activities met the standards for the U.S. The other group, however, was given a bunch of information about how movement and their daily routine was very good for cardiovascular health, it could be good for weight loss, etc. And then they tracked these subjects over a period of many weeks. The take-home message from this study was that simply being told that movement is good for you, can lead to weight loss, etc., led to significantly more body fat loss, waist to hip ratio changes in the direction that most people would want, essentially a slimming down, if you will, and all sorts of other positive effects on things like cardiovascular health, simply by the knowledge that movement and exercise can help various health markers. So this is remarkable, and it speaks to the power of the nervous system and the power of belief in governing aspects of our body and our physiology that one would otherwise think were outside our conscious control. Now, of course, any of you that think scientifically, which I imagine if you watch this podcast or listen to this podcast is all of you by now, probably thinking, well, maybe they just moved around more, or maybe they stood up and sat down more. Maybe they did something else that was different. And indeed, there's a strong possibility that they did things differently than the other group. But the mere knowledge that exercise is good for you, that movement is good for you, shifted their behavior and their physiology in the direction of enhanced weight loss, fat loss, etc. So how we think about a given set of activities affects how we perform those activities, and how we think and about and perform those activities has a real effect on our physiology. So somewhere between the hard and fast rule that governs fat loss and weight loss, which is if you ingest more calories than you burn, you'll either maintain or gain weight. Typically, you'll gain weight, although not always. If you ingest about as many calories as you burn, you'll maintain weight, typically. And if you ingest fewer calories than you burn, typically you'll lose weight. That's the kind of rule of fat loss. And yet we also have these belief effects which show, and this has been replicated again and again, that how we think about a process, whether or not we think it's beneficial, can change our physiology in ways that can be beneficial to us. And I was also really intrigued by something, which is that growing up, I think we all know people who can eat a ton and never seem to gain any body fat, or people who seem to eat very little and seem to gain body fat very easily. And I was always intrigued by that. So let's talk about fat utilization. Let's talk about how fat is converted into energy, which is sometimes also called fat burning. What I'd like you to know is that this is a two-part process. One is fat mobilization, and the second is fat oxidation or utilization. So the first thing that has to happen for body fat to get burned up or used and reduced is that it has to get mobilized. And that's a process called lipolysis. But I actually don't care if you know the name lipolysis. You just have to move that fat out of the position that it's in. You have to get it out of the fat cells. So the first step is to get those fatty acids moving around in the bloodstream, to get them out of those fat cells. And then they can travel and be used for energy. And that second part, remember, first part is mobilization. The second part is oxidation, is then those fatty acids, those are potential fuel. They're just potential fuel, but you haven't burned the fat yet. You've just moved it out of your fat cells. They're going to go into cells that can use them for energy. And once they are inside those cells, they're still not burned up. You need to oxidize them. Think oxidation is the burn up part. They need to be moved into the mitochondria. And then they can be converted into ATP, into energy. So just to really zoom out again to make sure I don't lose anybody, you got to mobilize the fat, then you have to oxidize the fat. You have to, in other words, you have to mobilize it, then you actually have to convert it into energy. If you just mobilize it and you don't convert it into energy, you don't oxidize it, it can be returned to body fat. And many of the things that the nervous system can do is to increase the mobilization of fat, but also the oxidation of fat. The conversion of these fatty acids into ATP in the mitochondria of cells is favored by adrenaline. Okay? And adrenaline is released from two sources. Adrenaline is released from the adrenal glands, which sit atop our kidneys and our lower back. And it's also released from the so-called sympathetic nervous system, although that name is a bit of a misnomer because it has nothing to do with sympathy. It has to do with stimulating alertness and promoting action of the body. There's a big mistake in the literature that is finally being corrected among those who know. The mistake in the literature is that the adrenal glands and the release of adrenaline is what stimulates fat loss and fat oxidation. In fact, it was thought for a long time that adrenaline swimming around in your body of when you're fasted, because fasting can increase adrenaline, or when you're engaging in intense exercise, or when you're stressed, is going to promote fat oxidation. That's actually not the case. The adrenaline that stimulates fat oxidation, the burning of fat, is coming from neurons that actually connect to the fat, not hormones like adrenaline that are swimming around in your system. It's a local process. And this is very important because it means that what you do, the specific patterns of movements, and the specific environment you create that can stimulate these particular neurons to activate fat, meaning to release fat, to mobilize it, and then to burn it, is going to be a powerful lever that you can use in order to increase fat loss. So what have we said so far? We've said that you got to mobilize, you got to burn fat, and that your nervous system is in control of that process. It's not just about calorie deficit. Okay, so let's talk about how to activate the nervous system in ways that it promotes more liberation, movement, mobilization of fat, and more oxidation of fat. So one of the most powerful ways to stimulate epinephrine, which is also called adrenaline, from these neurons that connect to fat and to thereby stimulate more fat mobilization and oxidation is through movement. But I'm not talking about exercise. The type of movement that I'm referring to is extremely subtle. And some of you may be familiar with this type of movement, but I'm guessing you're probably not familiar with what I'm about to tell you, which is that shiver or shivering is a strong stimulus for the release of adrenaline, epinephrine, into fat and the increase in fat oxidation and mobilization. But shiver is not just induced by cold, and there are other subtle forms of movement that can greatly increase fat metabolism and fat loss. There was a group in England during the 1960s and 70s that discovered a pathway by which subtle forms of movement can greatly increase fat loss. This is the work of Rothwell and Stock. They were aware that some people overeat and yet don't put on weight. Other people overeat even just a little bit and they seem to accumulate extra adipose tissue. What they did was they examined people who overate and did not gain weight. And what they observed was that those people engaged in lots of subtle movement throughout the day. In other words, they were fidgeters. And that's what they called them. I'm not going to do the British accent version of fidgeters. but Rothwell and Stock were British. What they found were people that overeat but don't gain weight as a consequence. And in fact, many people who had low levels of body fat had a lot of resting tremor, not of the Parkinsonian type, but they would bounce their knee while they were sitting. When they would talk, they would engage in very angular movements. They were sort of electric fidgeters, people that bounce their knee, people that have a head bob while they're listening, people that nod a lot, people that stand up and sit down a lot throughout the day, and people that pace burn anywhere from 800 to 2,500 calories more than the control group in the experiments that they looked at. And indeed, there's been a modern look into all this, and these numbers check out. That simply moving around a lot, even if those are subtle movements, greatly increases the amount of energy that you burn. And people who overeat, the people who can have the second or the third donut or donuts at all and don't seem to put on weight to the same degree, they are people that move around a lot even when seated. They're people that will often move their limbs very quickly as well. There even have been studies that have explored other things that correlate with fidgeters. Fidgeters stand up very quickly at the end of a lecture, or they start to gather their things very quickly, whereas non-fidgeters don't. So dogs like my bulldog Costello, definitely not a fidgeter. Every movement is incredibly slow and deliberate. Sitting down is a process. If you ask him to sit down, it's sort of a slow motion. You ask him to get up and he kind of looks at you, sighs, and stands up. The fidgeters are the opposite of that, right? You say, "How are you doing?" And they go, "Great." So even sometimes their speech will be accelerated, although not always. But staccato movements, fidgeting, etc. Now, why am I telling you this? Well, there's clearly a tool to export from this, which is that you can increase the amount of calories burned without having to go on additional long runs. I do hope that people are exercising regularly because it's so important for other aspects of brain and body health. But nonetheless, we are all time limited, and we are not all so ready to embrace exercise. Fat is controlled by these neurons and the epinephrine they release. You might say, well, how could these little micro movements lead to so much caloric burn? Those subtle movements of our core musculature, not just the core, but all our limbs and our musculature, those low-level movements, they trigger epinephrine release from these neurons, and they stimulate the mobilization of fat. And then that fat is oxidized at higher rates. Now it should make sense why shivering is one of the strongest stimuli that one can incorporate to stimulate fat loss. And there are two ways that shivering can increase fat loss. And there are several ways that you can use shivering, you can leverage shivering, and you can leverage cold to accelerate fat loss. But you have to do it correctly. So let's talk about how to use cold and how to leverage shiver as a particularly strong stimulus to increase fat loss through mobilization and oxidation of these fatty acids. Okay, so we have several kinds of fat, 3 kinds in fact. We have white fat, white adipose tissue, and we have brown fat or brown adipose tissue. And there's a third kind, which is beige adipose tissue. Now, cold exposure does several things. Making ourselves cold can allow us to build up mental resilience, because getting into cold of any kind, doesn't matter if it's a cryo chamber, doesn't matter if it's a cold day and you forgot your sweater or your parka, it doesn't matter if it's an ice bath or you're lying down in the snow. Cold causes the release of adrenaline from your adrenals, and it causes the release of epinephrine from these neurons that connect to fat. Now, the big effects of cold on metabolism and fat burning are going to be through 2 routes. One is that if you expose yourself to cold, you have the opportunity to trigger activation of brown fat, as well as to convert more beige fat into true brown fat. So you essentially create a stronger or a hotter furnace. That's the way to think about brown fat. It's like a furnace. And so with this principle that we started with of calories in versus calories burned, what you're doing is you're increasing the amount of burning, you're increasing the burn of energy by increasing the intensity of the heat inside you, so to speak. The paper published in Nature shows that it is shivering itself that causes the brown fat to increase your burning, your burn rate, and your metabolism. And it works like this. When you get into cold and you shiver, the shivering, that low-level movement of the muscle, those small movements, triggers the release of a molecule called succinate, succinate, succinate. And succinate acts on the brown fat to increase brown fat thermogenesis and fat burning overall. So let's talk about movement and the more traditional kinds of movement, aka exercise, that has been shown to lead to increases in metabolism and fat loss to greater degrees depending on whether or not, for instance, you're fasted when you do it or not, whether or not you do your cardio first or your resistance training first. And this is, again, in a literature for which there's a lot of controversy, but in digging through all the studies on this, we're finally starting to arrive at a consensus of when is best to do exercise and what types of exercise to do if your goal is fat loss. So we can think about high, medium, and low intensity exercise. Let's ask the question that I think many people are wondering about, which is it better, meaning do you burn more fat if you do your exercise fasted? And fasted in this respect could be that you wake up in the morning, you've been fasting all night, you just hydrate, and you exercise. Or sometimes people will ingest caffeine. There's controversy as to whether or not that quote-unquote breaks the fast. It has to do with whether or not you're caffeine adapted, something for another episode. In any case, that would be fasted. So probably not having eaten anything for anywhere from 3 to 24 hours or maybe even more. Because you could also be fasted in the afternoon if you had lunch at noon and it's 4 or 5 or 6 p.m. Will you burn more fat if you exercise without eating anything first, without ingesting any calories first? And people have tried to really split hairs on this every which way. People say, well, you can fat fast because fat and protein doesn't lead to as great increases in insulin as other things. Maybe you can have a few almonds and then still train. And indeed, insulin will prevent fat oxidation. I want to be really clear. The burning part of fat in the cell, the movement of the fatty acid and into mitochondria and the conversion to ATP, insulin inhibits that process. However, it's been shown that at least for short periods of training, it doesn't really seem to matter whether or not you eat before training or you don't, if your goal is fat oxidation. So once again, we've covered an enormous amount of material. We've talked about the science of fat loss. And in particular, we've explored this topic from the perspective of the nervous system, how neurons, and in particular the release of things like adrenaline, epinephrine, can facilitate fat mobilization and oxidation. I want to thank you for your time and attention today, and thank you for your interest in science.